Hello, my name is Nick, and this is my informative speech presentation about the time value of money. So, to first start it off, money does not have the same value at any given point in time, technically, and that's what I'm going to teach you about today in this informative presentation. So, the time value of money is based on the concept that a dollar today does not have the same worth as a dollar tomorrow or any other given point in the future. And this concept really just comes from inflation and interest based on where your money is and what you do with it. So when it's in a savings account, it makes a certain interest on it. And then when it's in cash, it doesn't make anything. And then just the overall inflation of the economy will decrease the value of your money. But you need to have the interest rate of what your money is making to make more money than the inflation is decreasing. And yeah, so like this is just the earning capacity of your money. So having your money do work for you. Whoa, that was not supposed to happen. Your button's stuck. Okay. So one way we analyze these cash flows is with a cash flow diagram. So as you can see here, you're putting in $3,000 yearly for the first 3 years, and then getting back $3,000 in the first year, $4,000 in the second year, $5,000 in the next year, and then $6,000 in the seventh year. And one thing to mention about these cash flows is that you cannot add them in different time periods. So when you move them from, say, the sixth time period to the fifth time period, you have to do a certain equation, which I will further elaborate on in the next slide. So here it is. Here's the governing equation for the present and future values of money. So the future value of money equals the present value times 1 plus the interest rate to the power of the number of time periods away it is. So say your interest rate is 10%, I would equal 10, and then say 5 years in the future, it would be n equals 5. And Excel is probably your go-to place for this with the PV and FV functions for previous or present value and future value respectively. So the next thing we can talk about is annuities. This is a yearly number, or I guess it doesn't even have to be yearly, but it's an equal number of payments in each payment period. This equal payment number does not mean it's the same value because they're not in the same time periods. So it can be annually, semi-annually, quarterly, monthly, weekly, even daily. And it can be paid at the beginning or end of each period, and I'll show you like what kind of effect that has on the value of your money. And then the Excel function for this is equals PMT function. And these are the cash flow diagrams I will calculate for you in Excel to show you how it's done. So let's start off with the PV and FV functions. So it's as simple as saying, so say you invest $3,000 into an account. You want to find out the value of your money 5 years later. The interest rate will be 10%. So we just go down here, we hit enters future value, and then it'll ask for the rate. Click on that, comma, number of periods, 5, comma, and click comma again because we're not doing a payment, we're doing a present value, so it's a one-time cash flow, 3,000, close the parentheses and click enter. So 5 years in the future with a 10% interest rate, your $3,000 will be worth $4,831.53. And now, so we can take that backwards. So say we have $3,000 in the future. We want to see what it's worth right now. We'll do the present value function with the 10% interest rate, the 5-year period, and then the future value of 3,000. So that value is worth $1,862.76. So definitely not worth $3,000. And then so for an annuity, say we're putting in $3,000 yearly for 5 years with a 10% interest rate, and we want to find out what's that worth to us right now. We'll do the present value function with the 10% interest rate, the 5 periods, and then the payments, the PMT will be the $3,000. Click enter, and right now you will need to have $11,372.36 to be able to put in $3,000 over 5 years. So just going back to the slides, So the power of investing early. This is really just what a lot of investors really think about is. So this diagram right here shows that if Susan invested $5,000 annually between the ages of 25 and 35, and then lets it sit for another 30 years, she will have accumulated 1.1 million. But Bill invests $5,000 annually between the ages of 35 and 65. So the second 30-year period that Susan didn't put any money in, he's only accumulated 602,000. So that just shows how the power of investing early and stuff. And then the second thing is interest. So it can be compounded in different periods. It can be yearly, semi-annually, quarterly, monthly, weekly, daily, or continuous. And this is the equation. The effective interest rate is 1 plus the annual interest rate divided by how many compounding periods to the power of how many payment periods there are in the compounding period, minus 1. And then there's also the continuous payment period. And this shows that if you do the equation, it shows that if you have a 10% interest rate quarterly compounded, it'll actually be greater than 10% yearly. And there's my works cited. And thank you for listening to my presentation.